So again, here we are, we're in Chapter 10. In Chapter 10, we're going to deal with performance tuning and system recovery. So our objectives, after completing this chapter, you should be able to describe backup and recovery of user data using file history, backup and restore from Win 7, and OneDrive. Describe recovery options for an unstable Windows 10 computer using recovery disks, Windows recovery, device driver rollback, system restore points, and system reset. And when it comes to performance tuning, it's a process rather than an event. Performance tuning process consists of establishing a baseline, recognizing the bottlenecks that exist, and then tuning that performance. To establish a baseline, you recognize system bottlenecks, you must first establish a baseline. The baseline is a set of performance indicators captured when system performance is acceptable. Performance indicators are often called counters. They display values for system characteristics. Now, establishing a baseline, you verify no unusual activity is happening on the workstation, so nothing strange is happening, and you measure performance indicators over time. So here's what it looks like when it's working. That's the mindset. Now, bottlenecks occur when a limitation in a single computer system, or the component itself, slows down the entire system. Disk bottlenecks occur when an application, they want to read and write information to the physical disk faster than that disk can actually manage. To increase disk performance, you upgrade the disks. You can implement mirrored storage spaces. You can move the paging file to a non-system disk. Now, memory bottlenecks they occur when applications require more memory than is physically required, or physically available, I should say. To reduce the use of virtual memory, you increase the amount of physical memory. Run fewer applications at one time. Now, there's processor bottlenecks, and they occur when there's too much work for a processor to actually perform. You resolve those by change to a faster processor. Now, processors, as we know at this point, they are hardware specific to the motherboard. We can add additional processors if the motherboard will accept them, and we can change to a multi-core processor if that's compatible with the motherboard. So it's all hardware dependent. Now, there are network bottlenecks, more common for servers than computers running Win 10, and multiple computers accessing a single server may overwhelm the network connection to the server. But we don't see this so much when we're talking about a Windows 10 system. Now, you deal with that by upgrading a network. It may involve replacing a network card, cabling, or switches. Now, when it comes to performance tuning, the steps are to create a baseline for the computer, compare the baseline to the current indicators. So it's what it's supposed to look like, what does it look now? Identify causes for those variations. Identify possible fixes for the variations from the baseline, and select a fix to implement. Implement the fix and monitor the changes. If it's not resolved, undo the fix and go back and do step 5 again. If it's resolved, document what took place for future reference should this occur again. Now, Performance Monitor, it's an MMC snap-in that's used to monitor system performance indicators. It's commonly called PerfMon, and that's people that have dealt with it for years, and it's been around for quite a while. Now, the areas we've got Resource Monitor, Performance Monitor, Data Collector Sets, and Reports. And here we are. There's Performance Mon, or PerfMon, and there's our areas that we talked about. Now, Resource Monitor provides real-time monitoring of the most common system performance indicators. Now, when it comes to the CPU, it's used to monitor processor performance. This processor ID uniquely identifies a single running process. By right-clicking a process, administrator can pause, resume, or stop that individual process. And we can see how much memory it's using. It's phenomenal resources. So we come into Resource Monitor, we can see what it is that's running, the ID that it has, a description, the status, is it suspended running, how many threads are being utilized, CPU usage. It works right on down the line. So that's for CPU. We've also got disk, network, and memory. We can see the CPU usage over here in a graph and see it over time as it relates to network usage, and we've also got disk usage and memory. Okay. So Performance Monitor, it's a tool within Performance Monitor that visually displays the data generated by the counters. You can view last, average, minimum. We saw that over on the right-hand side. We've got chart types. We can do a line chart, histogram, which is a bar chart, or an actual report. We've got data collector sets that organize multiple counters into a single unit and makes monitoring performance easier to manage. We can have performance counters, event trace, and configuration. Now the data collector set can log performance information to a disk for us, and that'll create the logging that we need over time to document it. We can start and stop it, and we've got alerts that can be triggered should something reach a certain level. So we just set whatever the trigger may be. When the trigger happens, we catch our alert. When it comes to Data Manager, a user can automatically control log files and reports that can be generated by the data collector sets. You can apply a policy and specific actions, and you can specify the parameters such as the minimum free disk space, maximum number of folders, report generation, deletion preferences to make room for new data. When it comes to reports, process and display log file data. You can specify rules to process log files. You can create your own rules for processing log files. Most administrators won't ever need to do so. Windows 10, the rules you're likely to need, they're already there. Let's move ahead. In Task Manager, we can see the different applications and processes that are running and how much processors being tied up or utilized, how much memory is being tied up or utilized, and same thing with disk and network. So when it comes to performance, we can see which services, which processes, which apps are beating up our system. And if it's something that is not something should be running or something we don't need, we can select that item and end the task. Okay. When it comes to the processes themselves, you can terminate the individual process, or you can terminate the process tree, which involves the associated processes along with that one process. Okay, so in Task Manager, aside from processes, we can look at performance, CPU performance, memory performance, disk performance, and the network or Ethernet performance. We can look at app history, startup, users, details, and services, and tasks associated with each of them. Now, there's an advanced tab that selects whether processor time is allocated to optimize performance for programs or background services. Now, if programs is selected, the program running in the active window is given a slightly higher priority than other applications. If background services is selected, all programs are given the same priority. Okay. Most Win 10 computers have only one hard drive or one hard disk. And increasingly, performance is not possible by adjusting the virtual memory settings. So you've only got one drive. changing the modifying the performance, it's not going to happen if you're changing virtual memory settings. Okay. So we've got DEP, Data Execution Prevention. Now the processor feature that Windows 10 can use, it monitors processes to ensure that they do not access unauthorized memory spaces. Now, some of you have seen in the past what's called a blue screen of death. And many times what that's generated, or what that error is generated by, is either an error in the disk itself or the drive itself, where memory's corrupt, no longer readable, whatever the case may be. The resource that's required, we can't get to it. Other times, the issue that's generated this blue screen, or this major fault, is that different processes are fighting over the same resource or same memory space. DEP prevents that. Make sure that things are protected, things that are vital to the OS are protected and can't be targeted by malware or be modified by other applications. So if we're going to troubleshoot Windows 10 errors, the more information you have about the problem, the more likely you can find a solution. Using precise search terms in a search engine will help you. It'll generate results more likely that are applicable to your specific problem. We've got a steps recorder. If you can't visit or view the user desktop, ask the user to record the steps using steps recorder. Steps recorder, it'll grab a screenshot, is captured each time the user clicks on a screen item, saves it in a .mht file, and then they can send it back to you, and you can see step by step what they did. We've got Reliability Monitor, and that rates the system stability of Windows 10 and lets you monitor the events that contribute to system stability. It collects data about software installs and uninstalls, app failures, Win failures, and other miscellaneous failures. Event Viewer is used to browse and manage events and messages stored in the system event logs. Now, you'll start Event Viewer as a standalone administrative tool, or you can use it in computer management. Most common events are errors, warnings, or different information, and logs are created so that we can go back and look to see what's taken place. So here's Event Viewer, and we can see there's errors, information, things that have happened over time, when it happened, the source where this event was triggered from, event ID, and the task category. So Event Viewer, it's a security log, system log, custom views, and subscription nodes. And we just showed you what it looked like when we're in Event Viewer. So we've got file recovery and backup in Win 10, and two features that exist in here: file history and backup and restore. That's from Win 7. If you want to configure file history, now file history allows data that is important to the user to be backed up to an external hard drive or a network location. To access file history, you must open Settings, click Update and Security, and then click Backup. Here's our little interface: Settings, Backup, and it'll get us where we need to be. We configure file history. Now, when you're attaching an external drive and configure it for use by file history, the drive doesn't get erased. Backup data is added to the drive. Here's our connection to that, where we're going to back it up and how. Go step by step right through it. Now, we can configure file history. There's administrator controls and utilities. They're limited with file history. We've got that configure, backup, and restore from Win 7. And here's what it looks like. When backup and restore is started for the first time, you select a target location for backup data. Users then can select that data to backup or let Windows choose it for them. And here's where we are on this backup and restore for Win 7. We can restore previous versions of files and folders if the file history or backup restore have been configured to protect user data. If they haven't, when it's gone, it's gone. So we can go through, and here's what we've got for a specific file and see the different versions over time. Here's our file history. Now, if we want to recover files from OneDrive, if it's stored in OneDrive and they're synced, they're cached locally. If a file is deleted within OneDrive, now it depends if you delete it from OneDrive using your OneDrive app through Win 10, you can still go back through the web interface of OneDrive and restore that. You can't do it from Win 10 or the Win 10 app, or I should say Win 10 or the OneDrive app, but you can do it from the OneDrive web interface. If a computer running Win 10 does not boot, you have to perform system recovery. Now, if you have restore points, it makes recovery so much easier. We've got a restore points, just a snapshot of the way things were set, how it was all laid out at a certain point in time. It goes back and makes it the way it was back at that point. If you don't have those restore points, you have nothing to restore it to. So we've got to have that enabled, turned on. And here's our interface. Now, if you got more than one restore point, you can back up to a previous or earlier time. If you back up to a previous or earlier restore point, anything that happened after that now will go away. Okay. So we've got driver rollback. Now, we've talked about drivers and what drivers do. Let's say that we decide I want to install the latest and greatest driver. Sometimes they don't necessarily work the way we want them to work, given a certain application, whatever the case may be. We want to roll back to a driver that was more functional for us. We can actually go in and roll back to a previous version of the driver. It keeps that for us in history, and each version of the drivers that we've had installed, they stay on the machine so we can roll them back if needed. And here we can see rollback driver. We've gone into a specific device, its wireless adapter, and look at the driver details, update the driver, or let's say we updated it today, it's not working right. Let's roll it back to a previous version, and we can go pick which version we want. We can have a recovery drive. It's created from an earlier, healthy OS. It contains a backup of the Windows system files and recovery tools to assist in the repair process. It's usually an external drive, but some devices support the use of high-capacity memory cards since, man, these memory cards can have a lot of information on them now. They're huge in data storage. We can also have thumb drives. Thumb drives, it's amazing how big they're getting today. So we can create a recovery drive, go in the control panel to do it. Requires administrative access to go ahead and run it. So we've got WRE or WinRE. It provides an automated diagnosis and repair of boot problems. We also get a centralized platform for advanced recovery tools. It's preloaded into most Win 10 editions. So here it is, advanced options. If you're seeing this, it's not a happy time. That means that you've gone to boot up, and for whatever reason, the OS is saying, yep, we got a problem. Whatever we need to do to boot up didn't happen, and here's your options. Do you want to restore it? Do you want to use your system image recovery? Do you want to go try to fix your startup? You want to jump into a command prompt to do it? Is it a UEFI issue that exists? Or are the startup settings wrong within the computer itself? Let me go modify those. Okay. We can do a system reset. If you're unable to repair a computer, it gave you options. It just didn't work. We can go through and do a system reset. We've got two options when it comes to the reset. Keep my files or just say, forget it. I want to start fresh. Okay. So when it comes to establishing a baseline for performance tuning, it allows you to recognize variations from normal system behavior and identify the system bottlenecks. What's causing the problem? Performance Monitor can monitor system performance. It can monitor system reliability, create alerts, log performance activity, as well as generate reports. We've got data collector sets that control logging of performance data and create alerts. Task Manager allows you to quickly view system process information. Performance options allow you to configure visual effects, processor performance, virtual memory, and data execution prevention. Now, you can gather information to help troubleshoot errors in Win10 or use Steps Recorder, Reliability Monitor, or Events Viewer. In Win10, recovery options include mechanisms to protect user data such as file history and backup and restore. If user data is stored in a cloud environment like OneDrive and synchronized to local copies of the data, the OneDrive can be used to restore files if there's a problem on the OS. The Win10 OS has many tools available for improved OS recovery. The recovery disk, system image backup, system restore points, and the WinRE environment. So I'll see you in the next one. That one wasn't as long as some of the longest ones, and it wasn't as short as some of the shorter ones. It should get shorter from here, and I'll see you in the next one.